12D Model and Revit. So using 12D Model with IFC and into Revit is quite advantageous to a structural drafter like me. Dirty word, structural, I know, in a civil tech forum. But using this information allows us to have greater collaboration between the two softwares. Previously in other projects, the challenges we've faced using various different methods to try and achieve 12D model into Revit. We use the 3D CAD method, EXDS XML generator, various different plugins, including Dynamo to try and re-replicate track slabs for light rail and a few other things. We're also using 12D tins, which are great. It's a 3D model in CAD, but there's no data behind it. So using IFC allows us to get all the data inside Revit and use this to our advantage. For those who don't know what IFC is, it's basically the industry foundation class, which allows us to exchange format between one authoring program and another. So let's start with 12D to Revit. Using this workflow, which I use on all projects going forward, we export an IFC model from 12D, 2x3 in Model 12, and up to IFC 4 and 4.1 in Model 14. Revit doesn't actually read 4.1 yet, so we have to stick with IFC 4. We're uploading this into the common data environment, whether that be your server, ProjectWise, whichever it is you're using, and we link or download, open this into Revit. So for those that don't use it, underneath the IFC, the data output tab, there's an IFC Express writer. This is the most simplest way to export an IFC file from 12D. If we break this down, there's a little XYZ coordinate shift box inside the IFC Express writer. This allows us to physically shift all the 12D model elements closer to 0 for Revit. Revit hates real-world coordinate elements. If it's outside a 16-kilometer range with inside Revit, it tends to distort and cause geometry problems that we can't actually use. We can use a few extra options where we export the attributes so we can see what's being modeled inside Revit, and using IFCSite from 12D tins to allow us to export a tin into a site category inside Revit. Once we've shifted the IFC, the 12D model closer to 0 for Revit, you'll see that by opening the IFC file, there's line 34, the IFC Cartesian point, which has actually re-replicated the number that we've shifted using the XYZ origin shift. Revit sees this IFC Cartesian point as its placement point inside Revit. So if we change this to 0, 0, that means we're telling Revit to place this IFC on its project base point. Now I'll show you a little video and a few examples on what happens if we don't shift this. Example 1. We have our model designed in real-world coordinates. We keep it at 0, 0 when we export it to IFC. We leave it unchanged. Regardless of what our project base point in Revit is, whether it be the real-world coordinate or 0, 0, it will still place 300,000 and 6 million kilometers away from where it actually is. Export example 2. We shift the model closer to 0 so Revit can read it. We don't change the IFC Cartesian point in the IFC file. Regardless of the number we choose, we still end up with element distortion. Example number 3. We shift it in 12D for our output. We change it to 0, 0, bring it into Revit, and we have perfect replication of the geometry inside the Revit space for us to use. So we've got to remember, when we're exporting from 12D to Revit in Model 12 version M, that we change the IFC Cartesian point. We make sure we shift the coordinate to the designated project base point inside Revit. And if we're doing exports to a coordination view as well as Revit, we have to do 2, because bringing in a project at 0, 0 in Navisworks is no good to most of us. But before we bring it into Revit, we have to set up a few options that allow us to map certain 12D elements and IFC classes to an appropriate site inside Revit. So by setting the IFC options, setting up a template with a predefined project base point, which allows us to generate a model in real-world coordinates, we also have to set an IFC mapping class, which allows us to map things like pipes that come out on an IFC element assembly to the pipes category inside Revit, 12D tins to a site category inside Revit, and as well as anything that's on a building element proxy, we can choose to map this to a generic model or something else. Linking the IFC file. When we link an IFC file into Revit, it's going to create a few extra automatic files. The most important one is the .ifc.rvt that's generated when we bring this in. This essentially creates a Revit project of the IFC file on the side for us to use and add a few view templates and things for project consistency. It also develops a log file in case there's been any problems that have come along, as well as a shared parameters file, which we use for mapping attribute data from 12D to a parameter inside Revit. So let me show you a quick little video on the process and what happens if you don't do it properly and how to fix it. So you can see here that I'm making sure that our project is got a project defined so we can bring in a site overall file and acquire it to real world coordinates. So if I make sure my IFC options are correct, make sure my mapping file is correct, you can see that I haven't got IFC element assembly in this list. Should be about there. If I load my 12D mapping file, you'll see that IFC element assembly has come in, and I can now map this to a pipes category for any drainage network information coming into Revit. If I find my IFC file and link it in, this has been exported using the origin shift coordinate, but you can see that it hasn't come in the right place. It should be pretty close to where that project base point is in Revit. And you can see I've eventually found it, but you can see that all the pits and pipes are distorted. It's effectively unusable. You don't have to detach this file and change it to get it into the right coordinate system. You can see that it's generated those 4 automatic files. I'm just going to open this in Notepad++, check that it's in the right schema. We're checking it's in IFC 2x3, and I'm going to go down to line 34 and change this manually to 0, 0. You don't have to do this individually for each file. You can actually use Notepad++ to search a bank of files, whether that be 30, 40, 50, even 3 if you're feeling lazy. And you can automatically change this file as it's the same on every single output that you do. So by just reloading this file, it doesn't take very long, you'll notice that it'll just disappear from the extremities of Revit, and you can see that all the pipes and the information has come in, not distorted, closer back down to where we need it. If I just flick at the shaded mode, you can see that the colors are coming through the same as 12D. All the pit and pipe data looks similar. It's going to appear the exact same way in here as it does in Navisworks, as well as similar to Solibri. There's a few little things that Solibri will do a little bit differently that I'll touch on in a bit. If you see, if I click on this pit here, that it's got a bit of element data on the left-hand side. So I'll go in and open up the .ifc.rvt to actually see what model elements have been generated. Interrogating this model allows us to see all different kinds of data that are coming through from the 12D attributes into Revit. If I highlight over this pipe here, you'll see that there's actually 2 pipes per pipe segment inside Revit. One is a building element proxy, which has no data inside it, nothing for us to use. And the other one that's come through is a pipe, which is a building element assembly, which is what I mapped it to prior to in the import options. But you see all the juicy data that we get on that left-hand side. It's got everything. So mapping your attributes and checking that your calculations are right is essential for when we're trying to interrogate something in Revit. And if I just load in my site overall plan that has it in real-world coordinates, you'll see that it's come into the exact same place that we need it to when we're trying to deal with these elements. The reason why we have to do this is because IFC inside Revit doesn't actually have a center-to-center option like it does for CAD. We have to do a bit of manual shifting for it to work. Revit coordinate systems are a little bit funny. So let's dig deep into what is actually generated when we put an IFC into Revit from 12D. You'll see that all the element information comes out from the 12D attributes, but it's a static model when we're linking into Revit. We can't change it, we can't manipulate it. All we can see is the accurate representation and all the element data behind it. If we look at the two side by side, they're almost, well, they are identical. The only difference is that the mapping color into Revit is is driven from the polygon color mapping inside 12D, whereas if you bring an IFC into Revit, it tends to go all white and has none of that associated details with it. So a bit of trickery, we can actually turn the edges off so we get no triangulation, which I'll show you soon, and we can work with this model. The string information from 12D is a really beneficial export to us. We can actually use these strings when we link in this model for pick line modeling. So if we've got a boardwalk and we need to use a 12D string of the bottom of the boardwalk that's been modeled, we can actually run a structural framing member that's supporting that around that 3D pick line, which allows us to have more accurate modeling and don't have to go through tricky, unnecessary steps in Dynamo to do this. You can see that they all respond to weight and color adjustments. I've thickened the shoulder lines to show line marking and made a control line out of the IFC strings from 12D, and used a bit of shading techniques to get our linked view plans looking the same throughout all our projects. In section view, we can see all the sublayers, all your curbs, all your tri-meshes that you've created. We can even annotate these. None of this text has been manually entered inside Revit. It's all been driven from the model parameters that have come out of the IFC file into Revit. Schedules automatically created. Every time we bring in the IFC file, if we look into the schedules properties, it's mapped each IFC element to a specific category inside Revit itself, allowing us to check data and use it for our own scheduling techniques when we're doing documentation. IFCSite. Similar to the tri-meshes that are coming out of 12D, we can use IFCSite to show our tins and super tins differently. You have to do is use a little bit of more trickery to get a super tin out. You have to actually re-tin it to be able to export this into IFC. But then we can show what's being removed, what's being retained, and we can use our color adjustments and line work to show this on our drawings as well. But of course, with all this, it's not its small little challenges. Polygon triangulation lines in Revit, hates it. Revit is not a great representation of complex geometry and civil design, so we end up with non-editable elements, is what I call them. It's basically an element that has, due to a polygon count, a close point that's too close to itself inside Revit, generally has a 0.8 millimeter of a tolerance. It breaks the shape and you can't actually adjust the elements in 3D or plan. You can't annotate any broken element. As you can see on the right-hand side image that I've got Eastings and Northings, RLs, but the ones that are broken from the top left image, you can't actually annotate or get anything out of. You can see all the data, but you can't use any of the annotation tools inside Revit. And if you reload this file, you break all the automatic annotation that's been created. The drainage network. Prior to Model 14, when you brought in a IFC file through Navisworks and Revit, it would actually not pick up the multiple pipes that are modeled inside the network editor. Revit and Navisworks don't read IFC systems, and this is the cause for that. So in Model 14, they're both coming through as an element of proxy now, and you can see the double pipes come through in the new version. But what good is this if we can't go back? So using the exact same reverse method, preferably IFC4, we can bring IFC data from Revit back into 12D. IFC4 keeps the file sizes smaller, allowing for more complex design from Revit using down to nuts and bolts, not that you really need them, but it keeps the file size from somewhere like 800 megabytes down to about 250, which comes quite nicely into 12D. There's a few little options inside the IFC Express reader that are basically, you can split the data into entity models, which essentially allows you to split the IFC into its element classes. You can either choose to use this if you want separate IFC models, or if you want one IFC as its own model package. As you can see in this instance, I've split them up into the IFC classes. So I've given it a prefix for the depot, and you can see it's broken down into IFC beam, building element proxy, flow segments, flow fittings. There's a few benefits to this is that sometimes in Revit, if we don't set our export options separately, we can actually bring in voids that we've used to cut walls and floors, and you can't actually turn them off very easy if you're bringing in one sole model. If you have a look at this, you can see that it's put a little bit of boxing around the complex items inside 12D, which basically allows for faster navigation, and until you zoom in, you can't actually see anything, and then it just pops in quite nicely. You can see all the data, get all your levels off it, and interrogate it. Section view, you can see they section quite nicely. You can see all the MEP services that have been modeled in and around the building, as well as the foundations and the culvert on the right-hand side that I've modeled. But if you go into the properties, you can start to interrogate each and every element that's come in from Revit. If you dig even deeper, you can look into the string attributes. Doing this brings great benefits to when you're trying to pick up a coordination problem with a Revit modeler, whether it be a conduit in the ground, a plumbing device, or a foundation. We can actually dig in and find the GUID element of Revit, which allows them to enter that GUID back into Revit and go directly to the item that you're having the problem with. But not only can you use this in a 3D sense in your sectioning, you can also use this in your civil documentation, so you don't actually have to remodel any of the cut and covers, the tunnels, retaining walls, any of the surfaces. It's all coming directly out in your annotated cross sections and building macros to be able to pick the levels of the tri-meshes that have been created inside 12D from these IFC elements. Another view of how you can see the coordination of how close the conduits have been modeled to the surface, as well as the foundations that we're interacting with. This is great because typically most people for retaining walls and tunnels, they want a long section of that element, which Revit doesn't do long sections. So we can spit out an IFC file to 12D and ask the civil designers to give me a long section along that wall and get all the information for us. So thank you. We can't only just use IFC for using it inside our own programs. We can use it inside Revit and 12D, that's great, but you can now use those elements inside Navisworks and on your final documentation. So that means you have 4 different areas and where you're coordinating, getting accurate and up-to-date information, which allows you to do a better detailed design job for your clients. Thank you.